Jason Walls from QA Cafe, and I am one of the co-directors of the Broadband User Services work area at the Broadband Forum and chair of the Connected Home Council. What we do in Broadband User Services, or BUS as it's colloquially named within the forum, is focus on the connected home and really the connected end user. And not for nothing, but nowadays, the blend between what is home and what is small office, home office, and what is enterprise is starting to all bleed together. So we really do try to focus on what a broadband connected end user has to deal with, and how providers and manufacturers and application vendors can all help monetize that relationship. So our flagship projects that most of you are probably familiar with include TR69, which at this point has very mature, has reached over 1 billion connected devices worldwide, which is pretty amazing. And that's basically the story behind the Broadband User Services Group is the invention of TR69, and that has evolved into what is now the User Services Platform, or TR369. And I'm going to talk about that the most today because it feeds into a lot of other things. But I wanted this slide to sort of give you a big overview of everything we're working on all at once, and some of the places you can get those resources. Obviously, that also means working on the data models for CWMP and USB. So the layers are very clear. The data models apply to both protocols and can be used for many other things too, but that's really where the majority of our work is right now, is always constantly adding more things to the broadband forum data models for the connected home. There's the open source projects that Lincoln was talking about. That includes the OB-USB agent, which is out on GitHub, and then OB-Map, which is still kind of in the design phases, but it's I believe it's still on GitHub right now, but it doesn't have a release yet. And that is for an open source version of the Easy Mesh protocol. And then lastly, also what Lincoln was talking about is TR398, which is the Wi-Fi performance testing. So why did we get to USP? If you've been on any of our previous webinars explaining USP and explaining TR69 and this whole journey, you might have seen this slide before. But it really is the evolution of the managed user experience and how that has happened over time. And it happened originally with, the invention of TR69 came about because we had never really thought about doing remote management of CPE, and it was very, very necessary, right? So relying on the end user to do things to set up their internet service or sending them CD-ROMs and stuff like that just wasn't working. So the industry got together and gave birth to TR69. And then that work, we just started managing more things. And it ended up evolving the data model into the device 2 data model, which is a much more efficient way of doing things and allowed us to add a whole bunch more new interfaces like IPv6 and better Wi-Fi. And that's when the cable and MSO industries sort of took over. And then the last few years, we started seeing this explosion of new technologies and new devices and new challenges. And it was time for us to sort of open the hood and see what we could do better. And that is when we created USP. And now USP continues to evolve. That includes the updates to the data model, but also updates to the protocol itself. We have a lot of participation from really, really great companies that are all using it right now. And I like to say that we're at the same point now that we were 2 years after TR69 was born. So you're going to see, I think this year and the next year are the times when you're going to see the explosion of USP coming. So what does it do? Mike was talking about this whole service-based architecture thing, and what we've designed USP, and it's named the User Services Platform for a very good reason. Its job is to help enable that ecosystem. That includes managed Wi-Fi and all of the analytics you need for monitoring. It includes building customer self-care applications that can be run on a phone or locally. It includes the containerized gateway that Mike was talking about too, and allowing third-party services to integrate with the home and allowing operators to make those relationships and deploy new applications on the CPE. It involves making a truly interoperable smart home. I mean, we have the protocol and data model objects now that allow you to build and manage things that have sensors and controls on them. and a host of additional interfaces that we're building in every single day. And we did that by stepping back and really thinking about what the use cases were going to be and deciding what the fundamental architecture things that needed to exist in order to make those things happen. By far the biggest one was the multi-controller architecture. So if you're familiar with TR69, you have a relationship between your CPE and a single ACS. And that was fine at the time because the job was to manage that particular CPE through the operator having total control over just every aspect of it, and primarily doing things like firmware upgrades and that sort of thing, and initial provisioning. But we wanted to open that up and be like, look, you want to have multiple controllers doing multiple things built by multiple people that, they might know about each other, they might not, but we have all of the hooks in place to be able to have a multi-controller architecture, including security and role-based access control and a host of other things. The next thing we wanted to make sure that we absolutely did was have an end-to-end messaging protocol that was secure from start to finish. And that is for situations where the protocol is going through other systems, or the messages are going through other systems, or they're going through like a brokered messaging service, and you want to make sure that compromise of that system doesn't end up compromising the entire the customer's data. So we have an end-to-end messaging protocol. We moved a lot of things that were RPCs in TR69 into the data model so that commands and events can be built flexibly and extensively. We wanted to make sure there was no dependency on cloud, so there are multiple message transfer protocols that we call them, so that the use case of being connected via a phone in your house is different from the devices connecting to their cloud services, and they'll both work even if the WAN goes down. And we set out knowing that the majority of the people who would be deploying this first are people who have already deployed TR69, and we want to make sure that it could coexist very easily with TR69. So we did that by maintaining backwards compatibility with the device to data model, among other things. The other thing we improved on was the proxy mechanism. So it's much easier in USP to control and manage things that don't speak USP at all. And that's very, very beneficial for the IoT and smart home stuff. And then we wanted to make sure that we defined a good REST API for the controllers themselves so that it can integrate into the larger cloud native infrastructure. What does that look like? Well, it really just means that USP is enabling all of these use cases to exist in a single ecosystem. So you can see here that there's a couple different kinds of controllers in different places doing different things. The bulk data collection mechanism that we had in TR69, we preserved that, we improved on it. So you can have the thing that's getting all your telemetry different from the thing that's managing your firmware, different from the thing that's giving the end user an interface to their connected home. And then of course that all works with the TR181 device to data model and all the things that it supports that you see down on the right hand side. Like I said, many of you might have seen this slide before. Whenever we're talking about USP, you'll see this slide, and it focuses on the fundamental tools that allow this particular infrastructure to work with. Some of the stuff here that is not necessarily on here because we are working on it now includes the stuff that Mike was talking about using USP to help build a smart gateway, a containerized platform that applications can be deployed on. Even though software container management has existed in TR69 for quite a while. Excuse me. All right. So I want to bring up this slide because it points on what Lincoln was talking about a little bit about everything working together very well. And that includes standardization, testing, and open source. So USP is more than just TR369. Everything can be found on the web at usp.technology. But it is also the TR181 data model. It is the BBF, the 369 certification with the associated test plan. And it is the open broadband USP agent, which is a reference implementation that can be used to build your own implementations. These things work together to make USP a very stable, long-term, future-proof solution. And that's how we like to think that standards should work. Okay, so that's the primary work, obviously, that we're dealing with right now is USP, but that ties into us improving the data model too. We're currently in device 2.14, version 14 of TR-181, and we are working on 2.15 as we speak. You know, I have it on here that we're always evolving. We have a very fast release cycle for the data model, something on the order of every 6 to 9 months. And right now we're working with the team that's doing OBMAP and other industry input to expand and improve the Wi-Fi statistics, because that's really the biggest pain point that operators are feeling right now, and you know, the application that people most want to deploy. And so that's constantly evolving. And you know, every time we find out new information that we can get from the underlying system, or things that operators want, or things that you know, the people who are specialized in making these Wi-Fi optimization applications, the things that they want to know, we're constantly evolving the data models to be able to provide and control those things. And then also in device 2.15, you're going to see some improved support for the cable industry in terms of DOCSIS interfaces and that kind of a thing. We've been working very closely with other open source projects to get USP within them, you know, like RDK or Purple Mesh and Purple WRT, and a number of other open source solutions, so that USP is becoming rather prevalent. I like to joke that Broadband User Services, the bus group, is the most fun that you'll ever have in standards, but we really do welcome all the input. You know, we always feel like, you know, we don't have any illusions about what happens in the real world when it comes to, you know, custom data models and that sort of thing. But if there's something that you really feel is missing, that is key to your own use case, and you feel like maybe the reason why it is key to your own use case is because it's probably helpful to other people too, by all means, please contribute to TR-181. We are always trying to improve it, always trying to make sure that these things get standardized, and we will absolutely help you do that. We're very welcoming, and we try to make sure that everybody can get what they need into the data model. And lastly, I did want to talk about 398 a little bit. Lincoln covered it pretty well. But you know, that's something that we're running through the Broadband User Services group in collaboration with the PHY-TX group that Alexandra's going to talk about. And so for that, you know, it really is meant to be performance metrics for access points that are done in a controlled laboratory environment with some things that you can definitely control, building clear pass-fail numbers that we built based on very rigorous trials, right? So there was kind of a beta period where we built those numbers. And so we're using that process now that we know it works very well for any future versions. Like I said, issue 2 includes support for AX and Mesh, and Lincoln talked about some of the stuff that we're working on in issue 3. And the certification for that is now available. Some people ask, you know, why it is that we decided to do this, and it was mostly from, you know, it was operator demand. They wanted the things on the left, and that is not to discount at all the things that are on the right. Like, the industry has done very well at designing, testing, and validation for the things that you see on the right-hand side of this. We want, you know, but there were some gaps that that operators were seeing. And we did it through the Broadband Forum to, you know, help test coverage and performance, including, I'd like to say, scalability as well, right? So how many stations can be connected and that kind of a thing. Ultimate capacity, long-term stability, which is incredibly important, and how it performs in the presence of interference. And it's meant to complement the testing that's already out in the industry. All right. Well, that's all I have, Ken. The one thing I did want to say is this is the main thing that we try to focus on at the Broadband Forum, and that is that we really believe that these three things together are what makes things work for the industry. It's what makes things able to be used by people to, you know, to realize their success. And the combination of these three things really do create solutions that are sustainable and scalable, that are long-term and don't have any vendor lock-in. There are obviously a number of solutions out there. Some are proprietary, and even some are open source, but ones that aren't based on this sort of process working together are the ones that are not going to be as long-term and end up in in lock-in situations. So when we've been designing standards in the Broadband User Services group, we always keep this little trifecta triangle in mind.